Hi everybody. So this is going to be my review for test 1, and I'm going to do this by going over some of the problems on the practice tests, right? So I'm hoping by now you've done all the homework and all the quizzes and have at least had some time to try some of the problems on the practice test, right? So I'm just going to start with number 1, part A. So we have two equations here. We have 6x minus 5y equals 7, and 2x plus 5y equals 9. Right? And we have to use the addition or elimination method. So we can eliminate x, right, by just multiplying the bottom equation by -3. Right? Again, on both sides. However, hopefully you realize that we don't have to do anything here. All we have to do is just add the two equations. We eliminate y automatically, right? Because one equation has a coefficient of -5, the other is a +5. So when you add them, they cancel, right? They add up to 0. So 6x plus 2x is 8x. -5y plus 5y is 0y, right, which is just 0. And that's going to equal 7 plus 9, which is 16. Okay, so we've eliminated y. And now we solve for x. Just divide by 8. And we get x equals 2. Okay, so that's half the answer, right? We're not done yet. We still have to solve for y, right? And the easiest way to do that is replace x with 2. We can use either the top equation or the bottom equation. Let's try the top equation, right? So instead of 6 times x, it's 6 times 2 minus 5y equals 7. 6 times 2 is 12. So 12 minus 5y equals 7. Right? Subtract 12 from both sides. You get -5y, that's supposed to be 5, equals 7 minus 12. So that's -5, right? So when you divide by -5 on both sides, we get y equals 1. So the solution to part A is 2, 1. And that's it. Right? So you should check, of course, by plugging both the x equals 2 and y equals 1 into both equations. What I'm going to do is show you that you could have just as well used the bottom equation if you replace x with 2. Right? You get 4 plus 5y equals 9. So take away 4 from both sides, and you get 5 times y equals 5. So when you divide by 5 on both sides, y is again equal to 1. Right. So that's another way to check, but I would plug both numbers into the original equations here to see if they work, to see if they're true. All right. So on to part B. So part B, we have again two equations and two variables here. We have 3x plus 10y equals 16, and 2x plus 7y equals 10. Right, so this one's a little trickier because we have to multiply both equations, right, by a non-zero number. And right, in my mind, it's probably easiest to eliminate x, right? You multiply the first equation by 2 on both sides, right? And the bottom equation by -3. Right. So where did these come from? Well, the 2 came from the coefficient from the bottom equation, and the 3 came from the coefficient from the top equation. But we want them to be opposites, right? So that's why the -3. Right? And the point of this is that the first equation, the coefficient of x will be +6. And for the bottom equation, the coefficient of x will be -6. So now when we add them, we eliminate x. 6x minus 6x is 0. 20y minus 21y is negative 1y. And 32 minus 30 is 2. So when you divide by negative 1, y is going to be negative 2. Makes sense? Right. So now we still have to find x. So going back to the original equation, I'll do the top one again. If I replace y with negative 2, I get 3x minus 20 equals 16. I'll give it some more space here. So add the 20 to both sides. And now we get 3x plus 0 equals 36. So if 3 times x is 36, divide both sides by 3, x is going to be 12. Okay, so if x is 12 and y is negative 2, then the solution to part B is the ordered pair, 12, negative 2. Remember, it's always x that comes first, and then y. Okay, and again, I'll leave it to you to check. All right, so now let's go on to part C. Part C. Hang on, I forgot what it was. So it looks like 7x plus y is equal to 1, and 6x plus 3y is equal to negative 2. Okay. Just making sure. So again, we can eliminate x if we multiply the first equation by 6 and the bottom equation by negative 7 on both sides. Right. On the other hand, we can eliminate y by multiplying the first equation by negative 3, right? Because the bottom equation has a positive 3. So let's eliminate y and multiply the top equation on both sides by negative 3. So this equation becomes negative 21x minus 3y equals negative 3. The bottom equation, we can leave that alone. And now just add them up. Negative 21x plus 6x is negative 15 times x. Negative 3y plus 3y is 0y, which is 0. And negative 3 plus negative 2 is negative 5. Right. So we have negative 15 times x equals negative 5. Divide by negative 15 on both sides. So x is negative 5 divided by negative 15. Now a negative divided by negative is positive, and we want to reduce this to its lowest terms. So the numerator is 1 times 5, the denominator is 15. 15 is 3 times 5, and 5 divided by 5 is 1, right? So the 5's cancel, and we're just left with 1/3. So x equals 1 over 3, 1/3. Right? Now we have to find y. And again, I've always used the top equation. We can use the bottom equation as well. So yeah, I think I'll do that, right? So we have 6x plus 3y equals negative 2. And now if x is 1/3, we have 6 times 1 over 3 plus 3 times y equals negative 2. So 6 times 1/3 is 6 divided by 3, right? 6 divided by 3 is 2. Okay. Subtract 2 from both sides. 3y is going to be negative 4. And now we just divide by 3. Divide both sides by 3. Y is going to be negative 4 over 3. And I don't know why I switched to yellow here, but the solution is the ordered pair 1/3, negative 4/3. Okay, yep, so, right, you can get fractions in your solution even though there were no fractions in the original equation, right? That can happen. Let's go on to part D. Now, again, I'm not going to do all these, but I'm going to keep going in order for the moment. So, number 1, part D, we want to solve 3x plus 4y equals 10. And the bottom equation is y equals negative 3/4 x plus 2. So this is set up perfectly to use the method of substitution. Right? Now, the directions, however, all the way up here, say that we want to use the method of addition or elimination. Right, not substitution. So unfortunately, yep, we're not allowed to use substitution here. Right. On the other hand, if that's the only way you can do it, then go ahead and use substitution. You know, you won't get full credit for it, but it's better than nothing, right? So lesson learned here, if you can't do it the way that they insist that you have to do it, using a certain method, you can use any method you want. Right? However, don't expect to get full credit. You're going to lose points for not following the directions, right? So let's use, again, the addition method. But to do that, we have to transform the bottom equation, right? We have to get, let's say, the x on the left side. So we're going to add 3/4 x to both sides. And so if we do that, we get positive 3/4 times x plus y equals 2. So now the x's and y's are both on the left, right? And I'm just going to copy down the first equation. Equals 10, right? The other thing we might want to do is get rid of the fraction here. Nobody likes fractions. So we can get rid of that if we multiply by the least common denominator, in this case 4. So multiply both sides by 4. And that becomes 4 times 3 is 12, right? So we get 12 over 4 times x plus, don't forget to distribute, 4 times y equals 2 times 4, which is 8. And 12 over 4 is just 3. So 3x plus 4y equals 8. So that's the bottom equation. But remember, this is the top equation, and they look awfully similar. So I'm going to copy them down again. The first equation is 3x plus 4y equals 10. The bottom equation is 3x plus 4y equals 8. Yeah. So they're awfully similar, right? But if we want to use the method of elimination, right, or addition, if we add the equations as they are, we don't eliminate anything. If we want to eliminate x, one of these should be a negative 3. So take your pick, top or bottom. I'll do the bottom. So multiply the bottom equation by negative 1. Okay. So I'll keep the top equation, 3x plus 4y equals 10. And the bottom equation becomes negative 3x minus 4y equals negative 8. So when you add them together, you get 0x plus 0y equals 10 minus 8, right? 2. But that's a problem here, right? 0 plus 0 is not 2. 0 plus 0 is 0. And 0 certainly does not equal 2. Right? This is false. So no matter what we choose for x and y here, we're not going to get any solution here. Right? So the answer to this problem is that there is no solution. Okay. So that's the conclusion when you end up with some ridiculous equation like 0 equals 2. Or, you know, your results might be different. You might get, you know, negative 1 equals 5. Or 7 is equal to 0, right? Any two numbers that are not equal, right, the equation is false. And so that indicates that there's no solution. Right. Right. I talked about this a little bit in the first video for 4.3, I mentioned that the two lines are parallel. And remember, parallel lines never intersect. So there is no point that these two lines have in common. Makes sense, right? Because the solution, right, when I say the solution is 1/3, -4/3, that's the point at which the two lines intersect, right? Yeah. So when two lines are parallel, they never intersect, therefore there is no solution. Okay, so that's why I wanted to do part D, because it's an unusual one, right? Most problems you're going to get are going to have one unique solution. This one happens to have no solutions, so just be aware of that. Okay, so I'm going to skip part E. I think you can handle that on your own. So I'm going to jump right to F, number 1, part F. We have 2x minus 3y equals 6, and 9y equals 6x minus 18. Okay, so, right, similar to the last problem where the x's and y's here are on the wrong side. They're on different sides. So why don't we first subtract 6x on both sides. So the bottom equation is going to end up being -6x plus 9y is equal to -18. Right? And then for the top equation, we had 2x minus 3y equals 6. Okay, now what? Well, it depends on which variable you want to eliminate. If you want to eliminate x, you can multiply the first equation by 3, because that'll make it a +6, and that'll cancel the -6. Right? If you'd rather eliminate y, you can do that. If we want to get the first coefficient here to be a -9, we just multiply by 3 again, right? So either way, we're going to multiply the top equation by 3, again on both sides. Okay. So when we do that, we get 6x minus 9y is equal to 18. And then the bottom equation, we can leave that alone. -6x plus 9y equals -18. So when we add these together, what do we get? 6x minus 6x is 0. Right? -9y plus 9y is also 0. And 18 minus 18 is also 0. So we get 0 equals 0, which is correct, right? 0 is the same as 0. This is true, right? This is a true equation. This is a true statement, right? So, so that's a different conclusion, right? When you get two numbers that are equal, that means that it's essentially the same line, right? If you draw the line for the first equation, and then for the bottom equation, you're drawing the same line. So every point on that line is a solution. Right? This has an infinitely many solutions. Okay, so we can't list them all. However, given an x, we can certainly find y, right? So the solutions are, right? Well, there's a couple ways of expressing this, right? The book might write it as the set of points x and y such that the equation is true, right? So we can use the bottom equation or the top equation because it's the same equation. 2x minus 3y equals 6. So use that, right? Right? So that's fine. The way I like to do it is I like to express y in terms of x, right? So if we solve for y, I'll do the bottom equation here. Just divide by 9, right? And you get y equals 2/3 x minus 2, right? And that's the same for the top equation as well. You'd get the same result. So you can also say the solutions are, right, the point x, and then for y is going to be 2/3 x minus 2. So I think that's how I have the answer in the back. Okay, so I think that should do it, right? There's three types of problems. One where you get one unique solution, right? A point x and y. That's one possibility. The second possibility is that you get no solution. And the third possibility is that you get, you get infinitely many solutions. Okay. And we did one of each. Well, for the first kind we did a couple of those already, so. And I think I'll do one more. How about part H? Okay, so here's part H. Number 1, part H. 4x minus 3y equals 23, and 5x plus 2y equals 0. Okay, so what do you want to eliminate, x or y? Doesn't matter to me. Let's eliminate x, right? So if we multiply the first equation by 5, that'll make it 20x. To make the bottom equation negative 20x, we need to multiply by negative 4. Again, on both sides, right? So the first equation will be positive 20 times x minus 15 times y equals 23 times 5, 115. And for the bottom equation, we're going to get negative 20x minus 8y equals 0. So add them together, we eliminate x, we get 0x, which is 0, right? Minus 23y equals 115. Okay, so just divide by negative 23. And y is going to be negative 5. Okay, so we know we get one solution here, right? But that's not it, right? Remember, a solution is two numbers, right? It's an x and a y, right? So far, we only have the y. Now we have to go back and find x. So how do we do that? For that, we can just use substitution, right? If we go back to, let's say, the first equation, 4x minus 3y equals 23, and if we replace y with the number negative 5, because that's the solution here, right? What do we get? We get 4x plus 15 equals 23. Subtract 15 from both sides. And we get 4x plus 0, right, equals 23 minus 15, which is 8. And then divide by 4, x is equal to 2. So the solution is 2, negative 5. Right. We don't need the x and y here, but I just wanted to make sure you understood that you needed both the x and the y in the solution. All right, so I think that should help for number 1. Let's go on to number 2. Okay, so these are the word problems that you get in section 4.4. Right. And this would be one of the easier ones, but let's go through it. Two numbers have a sum of 31 and a difference of 5. Find the two numbers. Okay, so remember the first step is to just give those numbers names. I'll just call them x and y. So let x and y be the two numbers. Okay. Right. The next step is, well, let's write down what the sentence means, right? The two numbers, x and y, have a sum of 31. What does that mean? It means sum means adding, right? So when you add x plus y, you should get the number 31. Right? What else do we know about these two numbers? they have a difference of 5. So that means when you subtract the two numbers, you just get 5. Let's try that again. There's a number 5, right? So there's your system of equations, right? Now you just have to solve that system of equations. You can use any method you want. We might as well use the addition method, right? When we add the two equations as they are, x plus x is 2x. I should use green here, sorry. X plus x, right, is 2x. Well, right, it's 1x plus 1x is 2x, right? Y plus negative y is 0, y minus y is 0, and 31 plus 5 is 36. So 2 times x is 36, divide by 2, x is 18. Okay. But remember, the question is to find two numbers. We only found one of those numbers. We need to find the other. So we found x, now we have to find y. Go back to the first equation and replace x with 18. And now we can find y, right? Subtract 18 from both sides. Y is, well, 31 minus 18, right? So that's going to be 13. So x is 18, y is 13. So now we can answer the question. The two numbers are 18 and 13. Right? And we can check. When we add the two numbers, the sum has to be 31. So 18 plus 13 is indeed 31. Good. And when we subtract the two numbers, the difference, 18 minus 13 is 5. So that's correct, right? So we know we have the two numbers. Right. So let's go on to number 3. Okay, so this is number 3. You are standing in line at a ticket window. There are 5 more people behind you than ahead of you. The total number of people in line, including you, is 3 times the number of people ahead of you. How many people are ahead of you? Okay, so this is a little bit of a tricky one. So let's go through it carefully here. How many people are ahead of you? That's what they're looking for. So let x be the number of people ahead of me, I guess. Yes. Right. And even though they don't ask this, we need to figure out how many people are behind us as well. So let's call that y. Y is the number of people behind us. Okay. Yeah, again, even though that's not what we're looking for, we need to designate a letter for that. And you'll see why in a second, because we need to get the two equations here, right? All right, so let's read the second sentence carefully here. There are 5 more people behind you than ahead of you. Okay. So I don't know. Let's say there's 5 people ahead of us, right? So let's say x is 5. Right. That's just a guess. I'm probably not right, but it's a guess, right? Right. So if the number of people ahead of us is 5, there are 5 more people behind us, right? So that means how many people are behind us? Well, 5 more than 5. That would be 10 people behind us, right? So whatever x is, right, to get y, you're just going to add 5, right? So again, 5 was a guess, right? If there's 6 people ahead of us, then the number of people behind us is 5 more, right? There are 5 more people behind us. So that would be 11 people. Again, that's probably not right, but it's a guess, right? So yeah, since we don't know how many people are ahead of us yet, we're calling that x. right, the number of people behind us, y, is just 5 more than that. So x plus 5. Okay. So already we have an equation, y is equal to x plus 5. All right. What else do we know? Well, we know that the total number of people in line, and that includes us, right, is 3 times the number of people ahead of us. So what does that mean? The total number of people, well, that's the number of people ahead of us, plus the number of people behind us, right? But including you, so including me, I'm 1 person, so plus 1. Okay, so that's the total number of people. So this is equal to, right, because the word is means equals in math, right? 3 times the number of people ahead of me. So 3 times, right, is 3 times x being the number of people ahead. Right? So we have our 2 equations, right? 2 equations and 2 variables, right? So let's write them this way. And that's supposed to be an x. All right. Right, and you can solve this any way you want, right? You don't have to use the addition method. In fact, I'm going to use the substitution method. I'm just going to take this y here and replace it with x plus 5. We can do that because they're equal, right? So I'm using the method of substitution. Right. But you can use the addition method as well. Right? So x plus y plus 1 is equal to 3x. But we know that y is equal to x plus 5. Right? So this is just x plus 5 plus 1 is equal to 3x. X plus x is 2x. And 5 plus 1 is 6. And that's still equal to 3x. Right? So if I subtract 2x from both sides, I get 0 plus 6, right, equals 3x minus 2x is 1x. So x has to be 6. And that answers the question. The question is how many people are ahead of us? The answer is 6. So I was right the second time. That was a guess, but you know. And the number of people behind you, of course, will be, 6 plus 5 will be 11. Right? And the total number of people in line, that's ahead of us, behind us, and us, is going to be, well, 17 plus 1 is 18. And 18 is indeed 3 times the number of people ahead of us. 3 times 6 is 18, right? So it works. So, yep, the number of people ahead of me is 6. Six people ahead. Okay, all right. So again, this was I think a bit of a tricky one. The others I think are more routine. Right. So let's jump to number 5. Okay, Judy deposits $20,000 into 2 savings accounts, one earning 3% interest, the other earning 4% interest, right? And this is simple interest, right? The total interest for both accounts was $740. Find the amount deposited into each account. Okay, so let's let x be the amount deposited into the, let's say, the 3% interest account. Let's let y be the amount deposited in the 4% interest account. Okay, you can abbreviate, that's fine, right? Okay, so step 2. right? I usually like to make a table here, although you don't have to. Right? So what do we have, right? We have the amount of money that we're putting into the savings account, and then we get interest, right, based on these percentages, right? So what do we have? We have the 3% account, the 4% account, right, and then we have the total. Right. So filling in the table here, the amount of money in the 3% account, we don't know what that is. We're calling it X, right? The amount of money in the 4% account, we're calling that Y. And the total amount of money, that's in the problem, right? That's the $20,000. All right. What about the interest, right? So how much are we getting in interest? 3%. 3% of X, right, is 0.03 times X. 4% of Y is 0.04 times Y. Yep. So don't forget to convert your percents to decimals. Right. And the total interest for both accounts, that was in the problem, that's the $740 here. Okay, so total means sum, right? So you're adding what's in both accounts. So the first equation is just X plus Y equals 20,000. The bottom equation, when you add the interest, you get 0.03X plus 0.04Y, and that's going to be 740. So those are our two equations, right? We just have to solve that system of equations. Well, first thing I would do is get rid of the decimals, right? We can get rid of the decimals if we just multiply by 100 on both sides. So we'll leave the first equation alone. It'll still be X plus Y equals 20,000. It's a weird equal sign. Let me try that again. Okay. And let's see, 100 times 0.03 is just 3. So 3 times X plus 4 times Y equals 74,000. Okay, so some big numbers, but no fractions and no decimals. We got rid of the decimals, right? So at this point, we can solve this system. Right? So that's step 3. We have to solve this system of equations. And you can use substitution if you want, but this is set up pretty well for the addition method or the elimination method. The bottom equation has a coefficient of 3x, so we want to multiply the top equation by -3 to cancel the +3, right? So multiply the first equation by -3. And we get -3x minus 3y equals -60,000, right? Right. And we can leave the first equation alone. In fact, we didn't even have to copy it down, but I think it might be better to do that. Right. So now when we add the two equations together, we eliminate x, we get 0x, right? And then -3 plus 4 is 1, right? So 1y equals -60,000 plus 74,000, which is just 14,000. So there we go. We can divide by 1, but we just get y equals 14,000. Okay. So that's half the answer. Now we still have to find x. But remember, the first equation is just x plus y equals 20,000. If there's 14,000 in the second account, in the 4% account, we know there has to be 6,000 in the first account, right? Just subtract 14,000 from both sides, right? And 20,000 minus 14,000 is 6,000. Okay. So to answer the question, and that's step 4, right? There was originally, right, in other words, the deposit, $6,000 deposited in the 3% interest-bearing account. And there was, again, originally, the original deposit, $14,000 deposited in the 4% account. Right. So there you go. That's number 5. I hope this helps. Okay, so let's go on to number 7. A 25% copper alloy. So an alloy is just a mixture of metals, right? So 25% copper alloy is mixed with a 60% copper alloy. How much of each alloy is needed to produce 70 grams of a 50% copper alloy? All right, well, step 1, what are we looking for? How much, right? So the number of grams, or measuring the mass of copper in grams for each alloy. So let's let X be the mass, which is the amount, right, the weight, essentially, of the 25% copper alloy. And we'll let Y be the mass, or the amount, of the 60% copper alloy. And what do we want? We want 70 grams of a 50%. Sorry, my percent symbols look weird, but it's supposed to be percent alloy, right? So this is what we want. How do we get there? Well, let's make a table. Right, so the first row is going to be what? Well, right, so what do we have? We have alloys. Those are mixtures, right? And then we have what's in the mixture is copper, and other metals too, of course. But we're worried about copper here, right? And we have the 25% copper alloy. We have the copper that's 60% or 60% copper, right? And then the mixture, when we mix them together, what we want to get is exactly 50-50, right? So 50% copper and 50%, other metals, right? So yep, we mix these together, that's what we want. So for the alloy, we have, right, X grams of the 25% plus Y grams of the 60%, and we want 70 grams for the 50% mixture, right? So that equation just becomes X plus Y equals 70. Right, so of the X grams, how much of that is pure copper? Only 1/4 of it, right? 25%, or 0.25 times X, right? For the 60% alloy, that means 60% is pure copper, so 0.6 times Y. And then for the mixture, well, it's going to be 50%. So 50%, or 0.5 times 70, that's just 35 grams. So 35 grams is pure copper, right? So the equation is 0.25x plus 0.6y is equal to 35. And that's our system of equations. So step 3, we have to solve this system. And again, you can use any method you want. If you want to use substitution, go right ahead. But I'm going to do the traditional elimination method or addition method. Right. And the first equation doesn't have any decimals, so I think we can leave that one alone. Just x plus y, right, equals 70. But the bottom equation, we can multiply by 100. In fact, it turns out we don't have to multiply by 100. I think if we just multiply by, I want to say 20, but I'm not sure. Well, yeah. All right, let's multiply by 100. Even though it's a little bigger than we need, it's probably the easiest way to get rid of decimals here. Right. So 100 times 0.25 is just 25, right, times x. And then 100 times 0.6, be careful, is not 6, right? It's 60, right? 60y. And then 100 times 35 is 3,500, or 3,500, right? Okay. Well, if we multiply the first equation by, let's say, negative 25, that'll cancel the positive 25 in the bottom equation. Right. So the top equation becomes negative 25x minus 25y equals, well, negative 25 times 70. So my calculator says negative 1,750. Okay. The bottom equation we can leave alone. Oops, right, that's 25x plus 60y equals 3,500. Add the two equations together to eliminate x. So 0x, and then 60 minus 25 is 35. So 35y equals, well, I think it's just negative 1750, or positive 1750, right? Because 1750 doubled is 3,500. Okay, so I think that's right. So now we just divide by 35 on each side. And I get y equals 50. Oops, sorry, y equals 50. But we're not done. We still have to find x, right? But we know x plus y equals 70. So if there's 50 grams of the 60% alloy, we just have to subtract the 50 from both sides, and we get 20 for x. Right. So that's it. That's our solution. Now we just answer the question. So part 4. Right, so the question was, right, find the amount of each alloy. And so we did that, right? There's 20 grams of the 25% alloy and 50 grams of the 60% alloy. So, right, so the number of grams, or I'll just say the amount. I think I'll write it that way. The amount of the 25% alloy equals blank. And the amount of the 60% alloy equals blank. Right, so we know there's 20 grams of the 25% alloy and 50 grams of the 60% alloy. And yeah, 70 grams total, right? 20 plus 50 is 70, so that makes sense. And then you can check the mixture equation, how much of it is pure copper, right? So yeah, you should get 35 grams of pure copper. Anyways, that's number 7, so I hope that helps. Okay, on to number 9. We have a plane travels 870 miles against a headwind in 3 hours. traveling with a tailwind, the plane travels 700 miles in 2 hours. Find the speed of the wind and the speed of the plane if there was no wind. Okay. Well, step 1, let's declare our variables, right? So instead of x, let's use w for wind. So w be the speed of the wind. Of the wind. And for the speed of the plane, p. Right? Let p be the speed of the airplane. Okay, so that's what we're looking for, right? Step 2, make a table. Okay, so what do we have? We have speed times time equals distance. It's one of those problems, right? Speed, time, distance. Right, and we have the two situations, right? You're traveling with the wind. So that's what's sometimes called a tailwind if it's coming from behind you. It's making you go faster, right? And then we have the headwind. I think I got it upside down, but I guess it doesn't matter. Yeah, the first statement is the headwind. So headwind, right? So this is against the wind. And then the tailwind is going with the wind. All right. Well, if you're going against the wind, you're slowing down, right? You're going slower than the speed of the plane. So it's the speed of the plane minus the speed of the wind. If you're going with the wind, then the wind is pushing you faster. So it's the speed of the plane plus the speed of the wind. Okay, so let's see. The first statement is the headwind. We travel 870 miles against the wind in 3 hours. So the time is 3 hours and the distance 870 miles. Right. Now, if you're traveling with the wind, the plane travels a distance of 700 miles in a time of 2 hours. So the time, 2 hours, and the distance is 700 miles. Okay. Now we just need the equations, right? So speed times time equals distance. Here's the speed, p minus w, times the time, which is 3, equals 870, right? So that's the first equation. And the bottom equation will just be the speed, right? P plus w times the time, which is 2 hours, right? Equals the distance, which is 700. All right. So you can do one of two things here. You can distribute the 3. Oops, sorry. That's right. Or, if you take my suggestion, I would divide by 3 on both sides. Right, so I would divide this by 3 on both sides. So 870 divided by 3 is 290. Right? So the first equation just becomes p minus w is equal to 290. Right? And for the bottom equation, we just divide both sides by 2. Right? So the 2's cancel, and we end up with p plus w is equal to 350. Okay, so that's our system of 2 equations and 2 variables. Right? And it doesn't get any easier than this. All you have to do is add them together, right? P plus p is 2p. Negative w plus w is 0w, right? Or just 0. Right. 290 plus 350 is 640. I think that's right, yeah. So 2 times p is 640. Divide by 2. P has to be 320. Right. And we'll get to units in a minute. But that's the answer. 320 right, miles per hour. All right, what about the speed of the wind? So now we need W. Well, if we know what P is, right, P is 320, then 320 plus W is 350. So to get the speed of the wind, to get W, let's subtract the 320 from both sides. 350 minus 320 is just 30. So the speed of the wind is 30 miles per hour, and the speed of the plane is 320 miles per hour. So that's step 4. Oh, step 3 was to solve the system. Sorry. Right, so step 4, the speed of the wind. Right. And then the speed of the plane. Right, without wind, or on a calm day, is blank, right? So the speed of the wind is 30 miles per hour, right? And the speed of the airplane is 320 miles per hour. You certainly don't want it the other way around, right? If the plane is traveling 30 miles per hour and the wind is 320 miles per hour, you're in big trouble, because that's one of the worst hurricanes I can imagine, if the wind is 320 miles per hour. You know, in a typical hurricane, you might get, 80 miles per hour, 100 miles per hour, even 150 miles per hour would be, probably a very intense hurricane. 320 would be insane. Okay, so yeah, don't reverse them, right? Make sure the speed of the plane is always faster than the speed of the wind. Okay. Right, so that does it for number 9. And let's just finish up the word problems, right? Number 10, suppose a hybrid car can get 36 mpg, that's miles per gallon, in the city, and 41 miles per gallon on the highway. The car drove 353 miles on 9 gallons of gas. How many of those miles were driven on the highway? So, there we go. Let X be the number of miles, or if you want to use H for highway, that's fine. All right, so let H be the number of miles driven on the highway. Right. And even though we don't need it, we need the number of miles driven in the city. So let C be the number of miles driven in the city. Okay. Yep. So that's step 1, right? Yeah. Right. Step 2. Make a table. Okay. Yeah, so this I think is also kind of a tricky problem, because this is not, there's no wind here, right? And there's no current, right? So it's not speed times time equals distance. I mean, well, right? The problem is we don't know anything about the time. It doesn't say how long the trip took, right? We know the distance, and we know the amount of fuel that we used. Okay? So the first row is just the distance that we traveled, right? So we have the distance on the highway and the distance in the city. And when we add them up, we get the total distance that we traveled. Okay? So that's just the distance on the highway is H. The distance in the city is C. And the total distance we traveled is 353 miles, right? So the first equation is just H plus C equals 353, right? And then we have, well, the amount of fuel that we use, right? So the amount of gas right? I mean, even though it is a hybrid, right, it does require gas, right? It's not completely electric. All right, so how are we going to figure that out, right? The amount of gas that we used. Well, remember, in the city, we get 36 miles per gallon, right? Right. So yeah, in the city, we get 36 miles for each gallon, right? And then on the highway, we get 41 miles for each gallon. Okay, so, right, so we don't know how many gallons we used, right? So let's say it's n gallons, right? Then in the city, we traveled c miles, right? And so the number of gallons then, if you divide by 36, right, n is just c divided by 36. So the amount of gas used in the city, right, is just c divided by 36, right? And so doing the same for the highway, how about if it's m gallons on the highway, right? Then if you multiply, you get the total number of miles, which is h, and that's what we're looking for, right? So dividing by 41, we get that the number of gallons is h divided by 41. Right? And we used how many gallons? A total of 9. So the bottom equation is h over 41 plus c over 36 equals 9. And that's our system of equations. Right. So let me just copy those down over here. So step 3, we have to solve this system. H plus c equals 353, and h over 41 plus c over 36 is equal to 9. Again, nobody likes fractions, right? But we can clear the denominators if we multiply both sides by the least common denominator. I'm going to guess that that's 41 times 36, right? So 41 times 36, I get 1476. So multiply both sides by 1,476. And when you do that, you should get 36 times h plus 41 times c is equal to 13,284. Again, big numbers, but at least we got rid of the fractions. Okay. So there's our new system without fractions in it, right? And at this point, the easiest thing to do is eliminate h or c. I'll do h again, so multiply by negative 36, again on both sides. So the first equation becomes negative 36 times h minus 36 times c equals 353 times negative 36. I get negative 12,708. And the bottom equation, we can leave that alone. Sorry, that should be a C there. And now add them together. So 41 minus 36 is 5. So we get 5 times C is equal to, well, 13,284 minus 12,708. I get 576. And when you divide by 5, you get that C is 115.2. This is miles now, right? So that's how far we drove in the city. Unfortunately, that wasn't the question. The question was how many miles were driven on the highway. So yeah, we're looking for H, not for C. Right? But don't panic, because we know that H plus C is equal to 353. Right? And now we know what C is, right? 115.2. Now we just do the usual subtraction. So H is 353 minus 115.2, which is 237.8 miles. Right. So that's the distance driven on the highway. Right. So distance driven on a highway, just to finish the problem. Is, 237.8 miles. Okay, I hope that helps. Yep, so again, this was a little bit of a tricky one. Just make sure you know how to do the speed problems, right? Speed times time equals distance, as well as the mixture problems, right? Like the copper alloy ones, and then the interest problems, of course, with simple interest. So either taking out loans or investing. One's just a matter of subtraction, and then the other is a matter of addition. But it's the same when you calculate the percent interest, right? Okay, so that should do it for the word problems, I hope. Okay, so we'll move on to rules of exponents, right, in Chapter 5. So again, I'm not going to do all these, but let's start with A, number 11A. We want to simplify. In fact, all these are simplify. 2 to the 9 times 3 to the 4 times x to the 11 divided by 2 to the 5 times 3 to the 7 times x to the 15. Right. So we're just repeatedly using the rule that says, here's the rule down here, right? When I have a to the m divided by a to the n, that's just a to the m minus n. On the other hand, if n is bigger than m, right, you can also think of this as 1 over a to the n minus m. Right, because remember, you want to get a positive exponent. So whether m minus n is positive, if it's negative, you might want to use n minus m and just flip it over, right? All right, so, yep, we just subtract 9 minus 5. Right? And likewise, we can, for the power of 3, we can subtract the 4 minus 7. Right? And for the x, we can subtract the 11 minus 15. Right? But since those are going to be negative, we can make them a positive exponent by just bringing them downstairs. So 2 to the 4th on top, 3 to the 3 on the bottom, and then times x to the positive 4, right? Right. So that's it, although I think they want us to evaluate the expression as well. So 2 to the 4th, 2 times 2 times 2 times 2 is 16, right? And 3 to the 3 is 27 times x to the 4th. So that should be the answer to part A. Okay. So let's move on to part B. Okay, here it is. We want to simplify 7u to the 13 w to the 6 times 3u to the 7 w to the 10. Okay. Well, right, order doesn't matter when you're multiplying. So I'm just going to do 7 times 3, and then u to the 13 times u to the 7, and then w to the 6 times w to the 10. Right. So 7 times 3 is 21. That's the easy part. Right. And then the rule that we're using here, a to the m times a to the n is just a to the m plus n. Right. So we just add the exponents, right? 13 plus 7 for the u, and then for the w, it's 6 plus 10. So 21, u to the 20, w to the 16. Okay. All right, I hope that was a fairly routine one. All right, so on to part C. X to the 0 times y to the 3 times z to the 7, and then the whole thing squared, right? So first thing I would notice is that anything to the 0, right, is just 1. So x to the 0 is 1. We're assuming that x is not 0 here, right? Clean that up, right? A to the 0 is 1, right? So this is just going to be 1 times y cubed times z to the 7 squared. Or just y cubed z to the 7 squared. Right, so the rule we need to use here is if we have, say, a product, a times b to the n, right, that exponent gets distributed to each factor. So a to the n, b to the n. Right, so here a is just the y cubed, and b is just z to the 7. Make sense? So in other words, the next step here, this is going to be y cubed squared times z to the 7 squared. Right? Just using this rule here. Okay. Now we need to use a different rule. When you have something to a power, and then we're raising that to another power, so a to the m to the n, it's just a to the m times n. Right? So in other words, we multiply 3 times 2 here for the exponent of y. For the exponent of z, it's 7 times 2. So 3 times 2 is 6, and then 7 times 2 is 14. So it's just y to the 6, z to the 14. Let me try that again. Y to the 6 times z to the 14. Okay? So that's part C. Right, part D, very similar, right? We have something, right, a product, all to the power 3. So we know that we just, write 4 to the 3 times x to the 3, also to the 3rd power, times y to the 7th, also to the 3rd power. Right, so 4 cubed, 4 times 4 times 4 is just 64. And then x cubed cubed, right? Be careful, you're not adding. It's not 3 plus 3. It's 3 times 3, right? So 3 times 3 is 9. And then 7 times 3 is 21. So 64, x to the 9, y to the 21. Right? And then let's go on to E. Okay, so we have in parentheses 4a to the 9 times 6a to the 5 divided by 12a to the 4. Right, so here we're really just multiplying, right? This is 4 times 6, right? And then a to the 9, 9 times a to the 5 divided by 12 times a to the 4. So 4 times 6 is 24. A to the 9 times a to the 5, right, is going to be a to the 9 plus 5, right, which is a to the 14. So 24a to the 14 divided by 12a to the 4. Right. So first, 24 divided by 12, we know that's just 2. And then a to the 14 divided by a to the 4 is a to the 14 minus 4. So 2a to the 10. Okay, so that's part E. Okay, r to the 4 times s to the 13, the whole thing to the power 5, divided by r to the 8 times s to the 15 squared. Okay, well, first thing I would do in the numerator here is distribute the exponent of 5. So this is r to the 4 to the 5 times s to the 13 to the 5, right? And for now, I'll leave the denominator alone. So now we can use the product rule, right? Or the power rule, rather, right? R to the 4 to the 5 is a to the m to the n, right? It's a to the m times n. So 4 times 5 is 20, right? Times s to the 13 times 5, 65. Right? And then divide by r to the 8 times s to the 15 times 2. 15 times 2 is 30. Okay, so now we're just subtract the exponents. Right? So 20 minus 8, the exponent of r, and then the exponent of s is 65 minus 30. And then divide by 1, right? So this is going to be r to the 12 times s to the, 35. Right? 65 minus 30 should be 35. And that's part F. Okay, part G. So negative 5, a to the 0, and then in parentheses, negative 2a cubed b squared all to the 4th divided by 8ab cubed. So where to start, right? Negative 5 is just negative 5. Not much we can do with that. But a to the 0, remember, is 1. So negative 5 times 1. And then everything in the parentheses gets an exponent, of negative 4. So including the negative 2. Negative 2 to the 4, right? A cubed also to the 4, and then b squared also to the 4th power. In the denominator, there's nothing we can do with that at the moment, so we'll leave that alone. All right, so negative 5 times 1 is just negative 5. Negative 2 to the 4th is negative 2 times negative 2 times negative 2 times negative 2, which is positive 16. A cubed to the 4th power, right? So I'm looking at this. We know we multiply 3 times 4. So that's the exponent is 12, a to the 12. Right? Likewise, b squared to the 4th power. 2 times 4 is 8, so b to the 8. Right. Divided by 8 times a times b cubed. So now we're making some progress here. Well, we can do 16 divided by 8. That's just 2. Right? So negative 5 times 2. Right? And then this is going to be 12 minus 1. So a to the power 12 minus 1 times b to the power 8 minus 3. So negative 10, a to the 11, b to the 5. Okay, so that's part G. Okay, part H, now we're getting a little bit harder here. X to the 4 over 6y all to the power negative 2 times, because it's parentheses, right, times y to the negative 2 over 4x to the negative 1 to the 3. Okay, so there's a lot of ways we can do this. First thing I would do is notice that this exponent here is negative 2. If you want to make it a positive 2, you can do that, but then you have to flip over what's inside. Okay? And then over here, well, we could do one of two things. We can leave it and just use the rules of exponents, or we can change these to positive exponents, right? The 4 stays where it is, but because this is x to the negative 1 in the denominator, in the numerator it would be x to the positive 1. And y to the negative 2 in the numerator becomes y to the positive 2 in the denominator. And the exponent of 3 stays where it is, right? Okay, so we got rid of all the negative exponents, at least for now, right? And now we just square everything inside the parentheses, right? So 6 squared times y squared divided by x to the 4th squared times, right? X to the 1 is just x, but then we have to raise it to the power 3, divided by 4 to the 3, and then y squared, also to the 3. Okay. Well, 6 squared, 6 times 6 is 36, right? Times y squared, divided by x to the 4 times 2, so x to the 8, times, and then x to the 3, divided by 4 cubed, 4 times 4 times 4, 64, right? And then y squared cubed, y to the power 2 times 3 is 6. Okay. So, in the numerator, we just have a 36 x cubed y squared. In the denominator, we have 64 x to the 8 y to the 6. Okay, so 36 over 64. What can we do with that? Well, right, so 36 is going to be, well, I guess we could do 6 times 6, but we can also do 9 times 4. Right? And 64 is, well, 16 times 4. Right? So we can see we can cancel the factors of 4. Right? 4 divided by 4 is 1. And now just subtract the exponents. Right? So we got 9 over 16, and then 8 minus 3 is 5. I'm not going to skip that step now. There we go. And then this is going to be y to the 6 minus 2. So we have a 9 in the numerator, a 16 in the denominator, x to the 5 in the denominator, y to the 4 in the denominator. Okay, so that was part H. Just to remind you, 11H. Okay, 14 times x to the negative 3, y to the 5th, all to the negative 1, y to the 9, all over, in parentheses, 2x y cubed, all to the 4th power, times x to the negative 5 times y. So this is 11I. Right, so now we're getting pretty tricky here. This is kind of a hard one. But let's just go step by step and apply the rules of exponents here. The 14 is on the outside, right? So 14, we leave that alone. Then in the parentheses, we get x to the negative 3 to the negative 1 times y to the 5 to the negative 1 times y to the 9. We leave that alone, right? In the denominator, we distribute the 4. So 2 to the 4 times x to the 4 times y cubed to the 4. And then we have x to the negative 5 times y. Right, so far so good? So now we just use the power rule. X to the negative 3 to the negative 1 is x to the power negative 3 times negative 1, which is positive 3. Right? And then 5 times negative 1 is negative 5. So y to the negative 5 times y to the 9. All right, divided by 2 to the 4th. 2 to the 4th, we've seen that already. That's just 16, right? Times x to the 4. And then y to the 3 times 4. 3 times 4 is 12. X to the negative 5 times y, right? All right, so we have 14, right? X to the 3. And then notice what we can do with y to the negative 5 times y to the 9. We can add the exponents to make it y to the power negative 5 plus 9, right? And then in the denominator, we have x to the 4 minus 5 times y to the 12 plus 1. So 14x cubed, y to the 4, over 16, x to the negative 1, y to the 13. Okay, so far? Right, now just, well, first of all, let's take care of the 14 over 16. That just reduces to 7 over 8, right? So we have 2 times 7, on the top, and then 2 times 8 on the bottom. So cancel the 2's. And you're left with 7 over 8, right? So 7 over 8. And then just subtract the exponents. 3 minus negative 1 is 3 plus 1, which is 4. And then 4 minus 13, right, is negative 9. But remember, no negative exponents. To make it a positive 9, we'll bring it downstairs. So 7x to the 4 over 8y to the 9. Right. And that was part I. 11I. Okay, so 11j, negative 3, a to the negative 4, b to the 5, all squared, times negative 2, ab cubed, all to the negative 3. So applying the usual rules for exponents, we get negative 3 to the 2, a to the negative 4 to the 2, b to the 5, also to the 2. And then we do the same thing, but with the negative 3 now, right? So negative 2 to the negative 3. We have a to the negative 3. And then we have b to the 3, also to the negative 3. Right? Okay, so negative 3 times negative 3 is 9. And then negative 4 times 2 is negative 8. So a to the negative 8. B to the power 5 times 2. 5 times 2 is 10. So b to the 10. And here's where it gets tricky, right? Negative 2 to the negative 3, right? Right? It's not negative 8. Remember, a negative exponent here means it's the reciprocal, right? So it's going to be negative 2 to the positive 3, but in the denominator. Same thing with a to the negative 3. If you want to make it a positive 3, you can bring it downstairs. And then this becomes b to the negative 27, right? 3 times negative 3 is negative 27. Right. So again, if you want to make them a positive exponent, we can bring it downstairs. In fact, let's do that with all these, right? So we have 9 times a to the 3 times b to the 10. And then in the denominator, we still have the negative 2 to the 3. Well, that's negative 2 times negative 2 times negative 2, which is negative 8. And then we have a to the positive 8 from upstairs, and then b to the 27 also from upstairs, right? So now all the exponents are positives. We still have a 9 on top and the 8 on the bottom, right? So when we subtract the exponents, we get a to the power 3 minus 8, but we know that's going to be negative 5. So on the denominator, we'll make it a to the power 8 minus 3. And then the same thing with b. Instead of doing 10 minus 27, which would be negative 17, we can make it b to the 27 minus 10 in the denominator, and that'll be a positive 17, right? So negative 9 over 8 a to the 5, b to the 17. Okay. Yep, we still have the negative from the negative 8, right? Positive divided by negative is negative. So that's 11j. Okay, 11k. So here's where it gets kind of tricky, because you might say, I don't know what k is, but k is a variable, sure, but you treat it just like any other exponent, right? So I would leave the first one alone. This is still y to the power 3k minus 5, whatever that is, right? Now notice that in the second factor here, this is just a to the m to the n, right? A is y, m is the 2k plus 3, right? And n is just 2. So what do we do with that? We multiply the exponents, m times n. So here we're just going to multiply the exponent y to the power 2 times 2k plus 3. Okay. And that we can work out by distributing the 2 here, right? So this is y to the power 4k plus 6, right? 2 times 2k is 4k, and 2 times 3 is 6. So far, so good. All right, what do we have here? We were multiplying two expressions, right? A to the m times a to the n. So here's where we add the exponents. Right, so this is my m, this is my n, right? A is just y. So we're going to add the exponents. This is y to the power m plus n, right? And when we add 3k plus 4k, and then negative 5 plus 6, we just get y to the power 7k plus 1. Okay, so that's it for 11k. And I think I'm going to have to clear this. All right, so finally 11L. X to the 3n plus 2 times x to the n minus 1 squared over x to the 4n. Again, we don't know what n is. It's just some number, right? Just deal with it as if it were a regular exponent, right? So like in the last problem, I'm going to leave the x to the 3n plus 2 alone for now, because in the next factor we have to distribute the 2, right? This is x to the power 2 times n minus 1, right? Which is really 2n minus 2. Okay, so that's the next step. The first factor, x to the 3n plus 2 times x to the 2n minus 2 all over x to the 4n. All right, so for the numerator here, again, we're just going to add the exponents, right? That's the usual product rule for exponents, right? So what do we have? We have x to the power 3n plus 2 plus 2n minus 2. Well, right, 2 minus 2 is 0, and 3n plus 2n is 5n. So the exponent of x in the numerator is 5n plus 0. Right, but 5n plus 0 is just 5n. Right, so now we're down to x to the 5n divided by x to the 4n. And so the rule we're using here, a to the m divided by a to the n, is a to the m minus n, right? We subtract these exponents. Right? So this is just x to the power 5n minus 4n. But 5n minus 4n is just 1n, or just n, right? So this is x to the n. Right? So all of this mess here is really just simplifies down to x to the power n. Sorry, it's supposed to be an n. And that's it for 11L. And that's it for number 11. All right, so these are all rules of exponents. Yeah, I cleared away all the other 11, but you can scroll back and check those out, right? So I did all of 11. So let's go on to 12. Okay, so convert to scientific notation, right? So it's 12a. And I'm just going to copy down the number here. This is, let's see, 52 trillion, 47 billion. I think that's right. So what would that number look like in scientific notation, right? So we know this is a big number, so this is going to be something times 10 to a positive number. That number, that exponent of 10, is just the number of times we move the decimal place. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? So 10 to the 13. So the decimal is right after the 5, 5.2047, and then the rest are zeros, so you don't have to write any more zeros there unless you want to. So 5.2047 times 10 to the 13. Okay, so part B, very similar, but now you're going the other way. Oops, 12b. So the number is 0.000000907. So what would this be in scientific notation, right? So where do we want the decimal? Right after the 9. Right? So this will be 9.07 times 10 to what power? So we move the decimal 1, 2, 3, 4, 5, 6 times, right? 10 to the 6. However, this is a small number, so it's going to be 10 to the negative 6, right? So 9.07 times 10 to the negative 6. Right. Part A was a big number, so we get a positive exponent. Part B was a small number. And, you know, what constitutes being a small number? Anything less than 1 is going to be small. And this is way less than 1, right? So, yeah, negative exponents for that. Okay, so that's number 12. Right, so for number 13, we're just going backwards. Part A is 1.25835 times 10 to the 9. That's in scientific notation. What would that look like in standard notation as a regular number, right? So we just take the decimal and we move it 9 times to the right because we want a big number, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the decimal. Right. So we put commas every 3 digits. So this is 1,258,350,000. Okay. And then part B, we have 4.3 times 10 to the negative 4. So this is going to be a small number. So I'll put the 4.3 over here. And we move the decimal 4 times, but to the left, right? So 1, 2, 3, 4 decimal. And we need a 0 here, a 0 here, and a 0 here. And I'll put a 0 in front as well. So 0.00043. Okay, so that's part B. All right, so these get a little trickier because now we have to compute these numbers and write them in scientific notation. Okay, so let's start with part A. We have in parentheses 5.1 times 10 to the 4. So that's one number. And then we're going to multiply by 4 times 10 to the 7. Okay. Well, when you're multiplying, you can do this in any order, right? You can do 5.1 times 4, right, times 10 to the 4 times 10 to the 7. So 5.1 times 4, right, is going to be 20.4. And then same rule of exponents here, right? This is going to be 10 to the power 4 plus 7. But 4 plus 7 is 11. So 20.4 times 10 to the 11. However, this is not in scientific notation, right? We need to move the decimal one more time to the left, which means we have to divide by 10. So to balance that, we have to multiply by 10, right? 10 to the 1. So we're going to get 2.04 times 10 to the 11 plus 1, which is 12. Okay. Right? So yeah, if you leave it like this, 20.4 times 10 to the 11, this is not in scientific notation. So you're going to lose points for that. Even though it is correct, it is equivalent to this. Right? So these are equal. But it says specifically to use scientific notation. And technically, this here is not scientific notation. So yeah, so that's not quite right. All right, part B is 3.2 times 10 to the 14 divided by 8 times 10 to the 9. Okay, so here's how I would do it. Instead of 3.2 times 10 to the 14 over 8 times 10 to the 9, I can do 32 divided by 8, I have a little more trouble with 3.2 divided by 8. So I'm going to multiply this by 10 as long as I also divide it by 10, right? So doing it this way, we get 32 times 10 to the 13 divided by 8 times 10 to the 9. Right? So 32 divided by 8 is just 4. And 10 to the 13 divided by 10 to the 9 is 10 to the 13 minus 9. But 13 minus 9 is also 4. So 4 times 10 to the 4. Okay, and that's in scientific notation, so that should work. All right, part C is another product. It's 3 times 10 to the 41 times 7 times 10 to the 64. Right, so very similar to part A, right? Just change the order. We'll do 3 times 7 first, and then 10 to the 41 times 10 to the 64 using the rules of exponents, right? So 3 times 7 is just 21, right? Times 10 to the power 41 plus 64, right? 41 plus 64 is 105. Right. Again, this is correct, but it's not scientific notation because we have 2 digits in front of the decimal. We're only allowed 1, right? So that means we have to move the decimal to the left 1 unit. So divide by 10 and multiply by 10. So when we do that, 21 divided by 10 is now 2.1. And 105 plus 1 is 106. So 2.1 times 10 to the power 106. Okay, and then, part D. 6 times 10 to the 23 over 2 times 10 to the 104. All right, so split this up. Do 6 divided by 2 times 10 to the 23 over 10 to the 104. Because 6 divided by 2 is 3. And this is going to be, well, subtract the exponents, right? 23 minus 104. So 23 minus 104 is negative 81. So 3 times 10 to the negative 81, and that is in scientific notation. Right. Now you might wonder, didn't I say earlier that you're not allowed to have negative exponents? That's true, except in scientific notation. In scientific notation, you are allowed to have 10 to a negative power. Okay, so yeah, so you don't have to write this as 3 times 1 over 10 to the positive 81. It's correct, it's just a little awkward to write it that way. So we do allow for negative exponents, but only in scientific notation, at least in this course. Okay, so that takes care of 14. Right, and number 15, these are just word problems involving scientific notation, right? So for 15A, the GPU in a standard Xbox One console has a peak theoretical power of 1.31 trillion flops, which is a floating point operation per second. So that's basically one, arithmetic operation per second, basically, right? Write this number in scientific notation and in standard notation. 1.5, I can't spell, trillion. Right, so 1.31 trillion. So what is that as a number, right? It's 1.31 rather, and a trillion is just 10 to the 12th power. Right, so that's scientific notation. In standard notation, it's 1,310,000,000,000. It's million, thousand. So I think that's it. So that's the standard notation. That's the scientific notation. Standard. Yep, that's all it is, right? So a typical measles virus, it's about 0.0000022 meters, right? And I'm guessing the coronavirus probably is a very similar size. Write this number in scientific notation. Okay, so just move the decimal to the right until you get the decimal right after the 2. So 1, 2, 3, 4, 5, 6, 7 times, right? So 2.2 times 10 to the negative 7 meters, right? Yeah, so very tiny, very tiny. You need a very good microscope to see a virus. And finally, part C. Sirius is a binary star system consisting of 2 stars separated by a distance of 1.9 times 10 to the 9 miles. It's 1.9 billion miles. So write it as a standard decimal number, right? So 1, and then we move the decimal to the right 9 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then just put in your commas every 3 zeros, or every 3 digits rather. Okay, and I'll leave the miles here. Yep, so 1,900,000,000 miles. Okay, so that's very far. That's pretty far apart. Okay, so I guess that's number 15. Now we go on to division for number 16. Okay, so I'm going to skip part A because I think it's pretty routine. I mean, if you're having trouble with part A, you're really gonna have issues here. You should contact me as quickly as possible. But 16b, we can do that one. It's pretty similar. I'm gonna write this as a fraction, right? So 24a to the 9 b to the 6 minus 42a to the 7 b to the 5 plus 30a to the 5 b to the 3 all over 6a squared b cubed. You don't have to, but I think that helps writing it that way. But because we're dividing by a monomial, a single term, we can split this up as 3 separate fractions. 24a to the 9b to the 6 over 6a squared b cubed minus 42a to the 7 b to the 5 divided by 6a squared b cubed plus 30a to the 5 b to the 3 divided by 6a squared b cubed. Okay, so now we just divide the coefficients and subtract the exponents. 24 divided by 6 is 4, right? A to the 9 divided by a to the 2 is a to the 9 minus 2, and we can do that in our heads, right? 9 minus 2 is 7. Times b to the power 6 minus 3, which of course is just 3, right? So 4a to the 7, b to the 3, minus 42 divided by 6, right, is 7. And then a to the power 7 minus 2, which of course is just 5, right, times b to the power 5 minus 3, which is b to the 2. And then 30 divided by 6 is 5. A to the power 5 minus 2 is 3, times b to the power 3 minus 3, which is 0. But remember, b to the 0, right, is just 1. Right? So we don't need to write this at all. This is just 1. So just erase it, I guess. Oops, not the 3. We need that. Okay. So that's the answer for part B, 16b. Let's go on to 16c. 6x cubed plus 7x squared minus 11x minus 15 divided by 3x minus 4. Okay, we're dividing by a binomial, 2 terms. So the trick that we did in the previous problem in part B does not work here. Right, so we're going to have to write this as a long division problem. The 3x minus 4 is the divisor, and the dividends, the thing we're dividing, 6x cubed plus 7x squared minus 11x minus 15. Okay, so I'm going to go through this a little bit faster than we did in the previous video. What are we dividing? 6x cubed divided by 3x, right? So that's just 2x squared, right? That's step 1. Step 2 is to multiply 2x squared times 3x minus 4. Oops, that's an x. When you distribute, you get 6x cubed minus 8x squared, right? And now flip the signs and add. That's step 3. Flip the signs, and when you add, you get 0 plus 15x squared, right? Minus 11x minus 15. But again, now we do this all over again. We take the first term of each, right? The 15x squared divided by 3x. Oops. So that's just 5x. And that's the next term of the quotient, 5x. So step 2, multiply 5x times 3x minus 4. So that's going to give us 15x squared minus 20x. Right? And this is where you have to be very careful, right? Remember to flip the signs. Make this a negative, make this a positive. Now when you add, you get 0 plus 9x minus 15. Okay, so be very careful. If you're getting negative 31x, it's because you either forgot to flip the sign or you're subtracting in some weird way, right? You shouldn't be doing that. Flip the signs and add. It's much easier. All right, back to step 1. Take the 9x divided by 3x, right? So 9x divided by 3x is just 3, right? The x's cancel. So the last term of the quotient is 3. Step 2, multiply 3 times 3x minus 4, and you get 9x minus 12. Flip the signs and add. Our remainder is negative 3, right? So the answer to the problem, if you write it all out, it's going to be 2x squared plus 5x plus 3. And then you can write plus negative 3 divided by 3x minus 4. That's fine. Or you could write this as 2x squared plus 5x plus 3 minus 3 over 3x minus 4. I am not picky about that. Right? Whether you're adding a negative or subtracting, it's the same thing. Okay, so that's 16C. So let's go on to D, 16D. 14x to the 4 plus 13x cubed minus 10x squared plus 13x plus 15 all over 2x plus 3. So again, we're dividing by two terms, 2x and 3. So this is going to be another long division. And this one's even longer than the last because we have 5 terms in the dividend. But no missing terms, right? No zeros here, right? So remember to include any missing zeros as placeholders. That'll come up later, right? All right, step 1, 14x to the 4 divided by 2x. So 7x to the 3. Oh, I made a mistake here. Well, it's not 13x squared, right? It's 13x cubed. Oh, I made it in both places. Oops. Yeah, I'm sorry. This 2 should be a 3 here, right? So that's my mistake. I'm glad I caught that right now. Yep, 13x cubed minus 10x squared. Shoot. Okay, right. Anyways, so going on, right? So we multiply 7x cubed times 2x plus 3 in our step 2. And we get 14x to the 4 plus 21x to the 3. And now we subtract, or we add the opposite, right? So we're going to change this to a negative, and we're going to change this to a negative as well, right? So 14 minus 14 is 0. 13 minus 21, right, is going to be negative 8x cubed, right? And then minus 10x squared plus 13x plus 15. So just bring those down. But in the next step, right, when we go back to step 1, we divide the negative 8x cubed by the 2x. So that's negative 4x squared. Okay, so multiply the negative 4x squared times the same divisor, 2x plus 3. That'll give us negative 8x cubed minus 12x squared. Oops, let's try that again. All right, flip the signs. They're both negative, so make them both positive. Flip the signs in the bottom row, right? And so we get 0x cubed plus 2x squared, right? Still plus 13x plus 15. Right? And now we divide 2x squared by 2x. So that's just 1x, or just x, right? So multiply x times 2x plus 3. And you get 2x squared plus 3x. Remember, this was 13. And now subtract, right? So flip the signs. Right now they're both positive, so change them to both negative, which means I got to erase the plus here. Looks a little better. Yep, so minus 3x instead of plus 3x. Now we add, and we get 0x squared. 13x minus 3x is 10x. So 10x plus 15. Right, and now we're almost done. All we have to do now is divide the 10x by the 2x, right? This 10x by this 2x. So that's just 5. Right, remember, it's x to the 0, which is 1. So 5, right? So multiply 5 times 2x plus 3, and that's 10x plus 15. One last subtraction, flip the signs and add. So when we flip the signs from both positive to both negative, we end up with 0 plus 0. So here the remainder is 0, right? So this divides evenly, right? So the answer is just 7x cubed, minus 4x squared plus x plus 5. You don't have to add 0 over 2x plus 3, because 0 divided by 2x plus 3 is 0, and 5 plus 0 is just 5. So you can leave it like that when there's no remainder. When there is a remainder, you have to include it, right? So make sure that if the remainder is non-zero, right, you include that extra term there. All right, let's move on. Okay, I'm going to skip E and go right to F, because I think F is more difficult than E, in my opinion. Right, so the divisor here is x plus 2, and the dividend is 5x to the 4 plus 7x to the 3. Here's where you have to be careful, right? Plus 0x squared plus 8x minus 5. Yep, this is why F is more difficult, because there is a missing term here. As I mentioned in the previous example, which didn't have a missing term, this one does, right? You're going right from x to the 3 to x to the 1, which means you're missing x to the 2. So there's a missing 0x to the 2. We have to include that as a placeholder. Right, remember that? All right, 5x to the 4 divided by x is 5x to the 3. And 5x to the 3 times x plus 2 is going to be 5x to the 4 plus 10x to the 3. Okay, flip the signs. They're both positive. Make them both negative. Right. So when you add, you should get negative 3x cubed, right? Plus 0x squared plus 8x minus 5. That's round 1. Round 2, right? Negative 3x cubed divided by x is just negative 3x squared. Right? You're really just decreasing the exponent by 1 here, right? So multiply negative 3x squared times x plus 2. And we get negative 3x cubed minus 6x squared, right? So they're negative, change them both to positive, right? Flip the signs and add. So you're going to get 0x cubed, you're going to get 0x squared plus 6x squared is 6x squared, right? Plus 8x minus 5. See, we need a column here for the x squares. Because if you didn't write this, you're probably either getting very sloppy here, or it's very condensed, or you're just adding unlike terms. So be careful. Right, so that's round 2. Round 3, again, divide 6x squared by x, and you get 6x. Okay, so multiply 6x times x plus 2. You get 6x squared plus 12x. Again, flip the signs and add. Erasing the plus sign every time here, but, right? So change them both to minus, and now when you add, you get negative 4x minus 5. Right, and we have one more round. Right, we have to divide the negative 4x by x. So the x's cancel, and you're just left with negative 4. So multiply negative 4 times x plus 2. You get negative 4x minus 8. I think I have just enough room to squeeze this in here, right? Don't forget to flip the signs. They're both negative, change them to both positive. And when you add negative 5 plus 8, you get a remainder of 3. I didn't mean to write it in red. Yep. So we do get a remainder here, right? So, yep, the answer is 5x cubed minus 3x squared plus 6x minus 4, and then plus 3 divided by x plus 2. Okay, so that's 16F. I know I'm running out of time here, but let's do 16G as well, right? Because here we have a couple of missing terms. We have x to the 4, right, plus 0x cubed plus 4x squared plus 0x minus 5, all divided by x plus 1. Right, x to the 4th divided by x is x cubed. Right, x cubed times x plus 1 is x to the 4 plus x cubed. Again, the signs are both positive. Let's change them to both negative. And when we add, we just get negative x cubed. Right. Plus 4x squared plus 0x minus 5. So now we divide negative x cubed by x. We just get negative x squared. So multiply negative x squared times x plus 1. You get negative x cubed minus x squared. Here the signs are negative. Flip them to positive. So when you add, you get 5x squared plus 0x minus 5. Okay, round 3. Divide 5x squared by x, and you just get 5x. So multiply 5x times x plus 1, and you get 5x squared plus 5x. Subtract, or flip the signs and add, right? So change them both to negative. Good enough? Yep. All right, so change them both to negative, and when you add, you get 0x squared, negative 5x minus 5. That's a 5, not an S. I know my 5s do look like S's. I apologize. This is my S. This is my 5, or at least it should be. All right, one more round. Negative 5x divided by x is just negative 5. Okay. So multiply negative 5 times x plus 1. You just get negative 5x minus 5. Flip the signs and add. When you add, you just get 0. So the remainder here is 0. but you get x cubed minus x squared plus 5x minus 5. Right. And that's 16g. Right. Again, it was probably a trickier one because of the missing terms here. You have to include the zeros, otherwise you're going to get a really big mess. Or you're just not going to get the right answer, so be careful. All right, last one, h. Okay, h. There's no missing terms here, right? So there's no 0x to anything, right? So this one's pretty standard, actually. So I'm going to go through this pretty quickly. 2x cubed divided by x is just 2x squared. So that goes here. When you multiply 2x squared times x minus 6, you get 2x cubed minus 12x squared. Okay. Flip the signs and add. So make the positive 2 a negative 2, make the negative 12 a positive. And when you add, negative 19x squared plus 12x squared is negative 7x squared, right? Plus 39x plus 30. So divide. Negative 7x squared by x is just negative 7x. So when you multiply negative 7x times x, you get negative 7x squared. Negative 7x times negative 6 is positive 42x, right? So flip the signs and add. You're going to make the negative 7x squared a positive 7x squared, and the positive 42x a negative 42x. I can erase. All right, and so when you add these, you just get 39 minus 42, yep, negative 3x plus 30. All right, one more round, I think. So negative 3x divided by x is just negative 3. So when you multiply negative 3 times x, you get negative 3x. Negative 3 times negative 6 is positive 18. Flip the signs and add, right? So the positive 18 becomes a negative 18, and the negative 3x becomes a positive 3x. Oh, that was a sloppy erase on my part here. All right. All right, so when you add these, you should just get 0x plus 12, right? So the 12 is the remainder. So the answer should be 2x squared minus 7x minus 3 plus 12 over x minus 6. Okay, and that's it. So I have to warn you about something, because some people say, well, wait a minute, what about 12 divided by negative 6? Isn't that just negative 2? Yeah, you can't do that, right? This is not 12 divided by negative 6. This is 12 divided by x minus 6. Okay, so nothing cancels here because, right, this is not a factor. These are terms, x minus 6, not x times negative 6. Right? So we're going to talk a lot more about this in Chapter 7 when we talk about fractions and when to cancel and when you cannot cancel, right? Basically, if you're adding or subtracting, you cannot cancel anything, right? If you're multiplying or dividing, you can cancel, right? So for example, if this was, let's say, 12 divided by 6 times x, well, sure, right? We can think of this as, right, 6 times 2 divided by 6 times x. And in that case, 6 divided by 6, right, is 1. Right? So this would just be 2 over x. But that same thing doesn't happen here, right? Because you're subtracting, not multiplying. So nothing cancels here. Don't do that, right? And again, if that's confusing, wait till Chapter 7, and we will explore this and make it abundantly clear when you're allowed to cancel and when you're not. So I hope that helps. And one more thing I should mention is that some of you might know the shortcut here. The shortcut is called synthetic division. Right. And if you're going on to college algebra, you're going to be using synthetic division a lot more, right? If you're not going on to college algebra, you don't need to know synthetic division, right? Or you're not going to, you're probably never going to use it, right? It's just that in this problem, it would have been a lot easier to use synthetic division. But, right, when you do the problem, you're going to probably just do it the usual long division way. But if you're curious and you want to know synthetic division, here's how that works, right? All you're going to do is write down the coefficients, right? The 2, the negative 19, the 39, and the 30. Because notice when we're adding and subtracting, we're just adding and subtracting like terms, the terms with the same exponents of x, right? Right. Now, here's where it gets a little tricky. On the outside, the number is not the negative 6, right? It's the opposite of that. It's positive 6. Okay, for reasons that when you get to college algebra, they'll explain that a little bit better. All right, so now it's pretty easy, right? Now you're just adding. Oh, here's why you change it to a positive 6, right? Instead of, it's like the same reason that you flip the signs here, right? If we flip the sign here, then we can just add all together here, right? So here's how this works, right? This is 2 plus 0, which is 2. 2 times 6, right, is 12. So that goes in the next column. Negative 19 plus 12, right, is negative 7. Negative 7 times 6 is negative 42. 39 plus negative 42 is negative 3. Negative 3 times 6 is negative 18. And 30 plus negative 18 is 12. Now that's not the answer, but if you look at the answer here, I'll copy it down. You can see the connection here. Right? These are just the corresponding coefficients. So all you have to do after this is just supply, right, the x's. Right? The last term is always the remainder. So that's where you get the 12 over x minus 6, right? This term is the constant, so there's no x with that. This term has the x to the 1, and then this will be x to the 2. Right? So that's how synthetic division works. If you didn't follow that or you don't understand it, don't worry about it, because on the test, you're just going to use long division here. Right? This is a lot faster, of course, using synthetic division. So sure, right, it's a nice shortcut once you learn it. However, keep in mind that for some of the problems we did, in particular, let's say C and D, synthetic division does not work quite as well. Okay, so yeah, in some cases synthetic division just doesn't work nicely at all. But in cases like this, it does work. And if you want to do it this way, be my guest. However, I would suggest sticking with just a long division for this course. When you get to college algebra, you will learn synthetic division, and you'll be doing that a lot because it's a lot faster. So that's all I wanted to say here. So I hope this helps. Good luck on the tests, and then in my next video we'll start chapter 6.